Alright, so we're going to look at number 6 and 7. For number 6, I notice I have 4 different transformations. Reflecting about the x-axis, vertical stretch by 2, I'm going to go right 3 units, and then down 1. Alright, 4 different transformations. So we're going to start off thinking about negative x squared. So I'm going to start off with the negative, because obviously my graph is negative, gives me the reflection down. What would just negative x squared look like? Negative x squared would start at 0, 0, and then flip down, so it would go positive 1, negative 1. 2 squared would give me 4, 3 squared would give me 9, and then I'd move off my graph. Well, I got to stretch those by 2 and then move right 3 down 1. So I'm going to start with this point right here. Well, the y value is negative 1. Negative 1 times 2 is 2. If I move right 3, I go 1, 2, 3, down 1, right there. Well, let's think about this point up here at the top. If I stretch by 2, that means I'm multiplying the y value of 0 by 2. 0 times 2 is still 0. So stretching that one didn't move it. But then I need to move it right 3 spaces. 1, 2, 3, and down 1. Put a point. For this one, it has a y value of negative 1. Negative 1 times 2 is negative 2. Go right 3 spaces. 1, 2, 3, down 1, and I got a point. And then if I want to do this one right here, this has a y value of negative 4. So negative 4 times 2 is negative 8. So come all the way down here to negative 8. Right 3 spaces. 1, 2, 3, down 1. Put a point. And I'm not going to bother with this next one because negative 9 times 2 would give me negative 18. It'd already be way off my graph. But I will think that my parabola is symmetrical. So if I'm starting to do my points, I see here, I come left 1, down 2, and I get this one. Here, right 1, down 2, and I get this point. Alright, I have this point right here. Well, for my parabola to be symmetrical, I need another point. Let's see here, this is 2 units over. So if I come back here to the middle where my center of my parabola will be, 2 units over, right there. That will be my last point on my parabola. There we go. And my parabola should look something kind of like that. If I come over here to number 7, number 7 only has 3 transformations. Vertical stretch by 3. We're going to go left 2 spaces and then up 1. And we're going to start off with x squared. What x squared look like? Well, x squared is at 0, 0. Goes over 1, up 1 in both directions. At 2, 2 squared is 4. Negative 2 is 4. 3 is 9. Be there. Negative 3 is 9. And then at 4, 4 squared would be 16. That would put me off the top of my graph. So those are the points I'm going to use. And then let's think here. What would multiplying by 3 and then going left 2, right, up 1. So left 2, up 1. We'll start at the very bottom. This one has a y value of 0. 0 times 3 is 0. Then I go left 2, up 1, and I get there. Well, let's do this point right here. This point has a y value of 1. 1 times 3 is 1. It would be right here at 3. And then I'm going to go left 2, up 1. And if I'm being symmetrical, that means this point should be right here. So that's the same on both sides, but let's see. This has a y value of 1. 1 times 3 is 1, 2, 3. And then I'm going, oops, 3 is right here in between 2 and 4. Y value is 1. 1 times 3 is 3 right here. 3 right, sorry, left 2, up 1 does get me right there. There we go. This one has a y value of 4. 4 times 3 is 12, so that shoots me way up here to 12. And then I'm going to go left 2, up 1, put a point. And I'm not going to bother with this one because that 9 times 2, 3 would give me 27 way off my graph. I'll move over to this point, which should be a y value of 13. This will be making it symmetrical, but let's see. 4 times 3 is 4 times 3 is 12, so go up to 12, left 2, up 1, put a point, and I do see my points are symmetrical, and I end up with a very, very thin parabola that I'm missing my point on. Sorry. See if I do better on this side. Alright, because it's very thin because it's been stretched by 3, and I kind of missed my top point right there a little bit with my parabola, but that's ultimately about what my parabola should look like, except that my parabolas tend to have pointy ends, and of course it should be curved at the bottom. Anyway, that's how you do numbers 6 and 7.